हाय एवरीवन, गुड मॉर्निंग। माय नेम इज़ विराज और मैं रहूँगा आपका फिजिक्स टीचर। इस सेशन में हम लोग जो है आगे पढ़ाई करेंगे, फंडामेंटल्स बिल्ड करेंगे, क्वेश्चन भी करेंगे और नीट के हिसाब से अपने टॉपिक्स को प्रिपेयर करेंगे। बट उसे स्टार्ट करने से पहले लेट्स लुक एट दिस फ्यू अनाउंसमेंट। हम लोग जो है न्यू बैच शुरू कर रहे हैं। ये अप्रैल 2025 से शुरू हो रहा है। ये 2 ईयर प्रोग्राम है। ये प्रोग्राम उन बच्चों के लिए हेल्पफुल रहेगा जो बच्चे 10th से 11th में जा रहे हैं और अपना नीट यूजी का प्रिपरेशन के लिए वन स्टॉप सॉल्यूशन ढूंढ रहे हैं। देखिए, इस बैच में बायोलॉजी सचिन सर और वर्षा मैम पढ़ाएंगे। सचिन सर का एक्सपीरियंस देखिए, 25 ईयर्स ऑफ एक्सपीरियंस। जितना आपका एज नहीं है उससे ज़्यादा साल से सर पढ़ा रहे हैं। ठीक है, तो आप बायोलॉजी जो है हमारी टीम पे जो है एकदम 360 मार्क्स यहाँ पर छोड़ दीजिए, आपका पूरा सिक्योर हो जाएगा। विनीत सर कोटा के बहुत बड़े टीचर हैं केमिस्ट्री के, 12-13 साल से कोटा में पढ़ा रहे हैं। सर एटीपी स्टार जो है उनका अपना इंस्टीट्यूट रन करते हैं विच इज़ इन कोलेबोरेशन विद iQuanta नाउ। मैं आपको फिजिक्स पढ़ाऊंगा। ठीक है, मैं पिछले 8-9 साल से फिजिक्स पढ़ा रहा हूँ। 2016 से बिट्स पिलानी से मैंने अपना ग्रेजुएशन किया है और मेरे पढ़ाए हुए बच्चे बहुत सारे ना कि जब भी MBBS में हैं बल्कि ऑलरेडी डॉक्टर भी बन चुके हैं। ठीक है, तो ये बैच उनके लिए रहेगा। इस बैच में जो फीचर हैं बेसिकली लाइव क्लासेस थ्योरी में रहेंगी, एक लाइव एप्लीकेशन क्लासेस रहेंगे जिसमें हम क्या करते हैं, सिर्फ आपको लाइव क्वेश्चंस भी कराएंगे जो आपकी बुक्स आपको सजेस्ट की जाएंगी, ना कि आपको करने को बोला जाएगा बट कि हमारी तरफ से भी कराई जाएंगी। तो यहाँ पर आपको लाइव थ्योरी क्लासेस, लाइव एप्लीकेशन क्लासेस और जो आपके जो डाउट सॉल्विंग के फीचर हैं 24/7 डाउट सॉल्विंग के लिए। आप कभी भी आपका डाउट है यू कैन पोस्ट इट एंड गेट इट सोल्व्ड। ठीक है, 8 से 9 मिनट के अंदर आपका जो है डाउट आपके पास रिजोल्व होकर के पहुंच जाता है। ठीक है, सेकंड बैच जो हम लोग जो है 12th के लिए, जो 11th से 12th में जा रहे हैं और जिनको लगता है कि उनका 11th वीक रह गया, उनके पोर्शन जो है कुछ कमी रह गई, अच्छे से प्रिपेयर नहीं कर पाए या खुद ही सीरियस नहीं थे, सीरियस थे बट स्कूल के साथ मैनेज नहीं कर पाए, तो उनके लिए जो है संजीवनी बैच 1 ईयर प्रोग्राम है। टीम हमारी वही एक्सपर्ट की सेम रहने वाली है। ठीक है, इसमें इंद्रजीत सिंह सर जो है हमारे फाउंडर एंड CEO, ये आपको कंसिस्टेंटली मेंटरशिप और गाइडेंस के लिए अवेलेबल रहेंगे। ठीक है, और आपसे बीच बीच में जो है इंटरेक्टिव सेशन रखेंगे जिसमें वो आपको लाइफ कोच की तरह जो है अच्छे से गाइड करते रहेंगे कि अप्स एंड डाउन्स आप एग्जाम के टाइम में मैनेज भी कर पाओ। क्लियर? तो ये 1 ईयर कोर्स रहेगा, नीट फोकस रहने वाला है और इसमें भी आपके लाइव एप्लीकेशन क्लासेस जो है 12th के लिए, लाइव थ्योरी क्लासेस, प्रैक्टिस, AI बेस्ड मॉक टेस्ट सीरीज। ठीक है, तो सारे फीचर जो एक अच्छे कोर्स के अंदर होने चाहिए, जो बेहतरीन कोर्स के अंदर होने चाहिए, वो सारे इन दोनों बैचेस में आपको मिल जाएंगे। ठीक है, इसके लिए सर हमें इनरोल कहाँ से करना पड़ेगा? अगर इन बैचेस में आप इंटरेस्टेड रहोगे तो आपको iQuanta की वेबसाइट पर जाना है और वहाँ पर नीट के कोर्स के लिए इनरोल करने के लिए जाओगे तो आप ढूंढ लोगे। ठीक है, और इसके अलावा आपको जो डिस्क्रिप्शन में देखिए वो एक व्हाट्सएप ग्रुप का भी लिंक दिया हुआ है और एक गूगल फॉर्म डिस्क्रिप्शन में दिया हुआ है। उस गूगल फॉर्म को आप फिल कर दीजिए और उसमें अपना क्वेरी रेज कर दीजिए कि मुझे सर ये प्रॉब्लम हुई है, जैसे 11th मेरा 50% हुआ है, मैं बाकी जो है नहीं कर पाया। तो डिफरेंट क्वेरीज जब हमारे पास आएंगी तो हम उसको बेटर तरीके से रिजोल्व करने में हेल्प करेंगे। ठीक है, वी कैन कीप सम जूम सेशन, वेबिनार ऑल्सो विद यू, ताकि हम लाइव इंटरेक्शन जो है कर पाएँ और आपके जो है क्वेरीज को रिजोल्व भी कर पाएँ। ठीक है, आपको किस तरीके से जो है एग्जाम को डील करने में जो जो मुश्किल हो रही है क्वेरी में आप पुट कर सकते हो। ठीक है, तो गूगल फॉर्म भी फिल कर दीजिए और व्हाट्सएप ग्रुप ज्वाइन कर लीजिए जहां पर आपको जो हम लोग फ्री स्टडी मटेरियल शेयर करते हैं, क्लासेस की इन्फॉर्मेशन आती हैं। ठीक है, और जो भी नीट से रिलेटेड कोई भी अपडेट या कोई भी एग्जाम अपडेट आपको मिलता है तो उस ग्रुप में शेयर कर दिया जाता है। ठीक है, तो दिस वॉज सम अनाउंसमेंट। सो लेट्स स्टार्ट द चैप्टर एंड अच्छे से पढ़ते रहिए। बेस्ट विशेष। तो चलिए स्टार्ट करते हैं लेक्चर को। लेट्स स्टार्ट दिस कोर्स विद one of the fundamental unit of physics which we call as vectors. Vector is a part of mathematical tools and the theory which we will be studying in this chapter will be used in mechanics and even in SHM waves, even in electrostatics and magnetism. So without vectors I think you cannot prevail in physics. So what are the key concepts that we will be studying in this chapter? Let's start with them. So we will be dealing what is vectors and what is unit vectors. We will be studying vector laws of addition, resolution of vectors, both 2D component and 3D component we will be dealing with. scalar and dot product, vector and cross product, because these two are the parts of vector multiplication. So we will be dealing with vector multiplication, summation and subtraction, then multiplication. We do not have division in vectors. Okay, vector division is not allowed. And then we will be solving problems alongside when we will be dealing with these topics. This is the topic flow we will be dealing with. Let's start our chapter with first topic, which we say physical quantity. What do you mean by physical quantity? See, physical quantity is anything which can be measured directly or indirectly. Like there should be some quantification. You can express that quantity in terms of some numeric value. So that is called physical quantity. And physical quantity are classified into two types, mainly two types, scalar and vectors. What do you mean by scalar? Scalar is that quantity which has magnitude only. Okay, so if some of the physical quantity do not have directional sense, that is called as scalar. For example, if you see mass, so mass has magnitude, product of numerical value and unit. So whenever we express a physical quantity, so physical quantity is always expressed in terms of numerical value and unit. There are two components. So this is the numerical value and this is the unit. So in this way we can express a physical quantity. And if this quantity do not have a directional sense, that is there is no feeling like no directional sense is attached to this physical quantity, then it is termed as scalar. If there is some directional sense, like for force it is there, force 5 Newton force along east, 5 Newton force along north, so it has a directional sense. But 4 kg mass along east, it do not make any sense. It is absurd statement. Okay, so scalar is someone which do not have directional sense, only magnitude is there. Scalar quantity can be added and subtracted and multiplied by simple law of algebra, which you have already studied up till your class 10th. Okay, so the normal multiplication, addition, subtraction, division are applied to scalar quantity. But when it comes to vector, what do you mean by vector quantity? Let's see. Vector is defined as with the following three properties. It has a definite magnitude. First of all, if it is a physical quantity, then it must be measurable. So it must have a definite magnitude. Then it must have a specified direction, that is unique direction. This is the second property. A vector must have a unique or specified direction. Then third, it must obey vector laws of addition, laws of vector addition, which are parallelogram law, triangle law of addition, polygon law of addition, which we will be dealing in this chapter in few minutes. Then it is said to be a vector. So the three basic properties are required: definite magnitude, unique direction, and it must follow vector laws of addition. Then we can say this quantity is vector quantity. Clear? If any of the above condition is not satisfied, then physical quantity cannot be termed as vector. And one more note, important point. If a physical quantity is a vector, then it must have a directional sense. But converse is not true. That is, that the converse may or may not be true. May or may not be true. Yani ki if physical quantity has a direction, then it may or may not be a vector quantity. Just like current. Current, if you see, it has both magnitude and direction, but it does not obey vector laws of addition. If you see this example, so what will they? They do not obey parallelogram law of addition. Which are the quantities? Pressure, surface tension and current. So they are not termed as vector quantity. Clear? So vector has following three properties: magnitude, direction, and there is vector laws of addition, they always follow. Now how do we represent a vector? Vector is always represented by an arrow. Okay, on the page, if you try to make an arrow which has a definite length and a unique direction, then it can be termed as a vector. It can be termed as a vector. Okay. What is this? This is the head part, this is the tail part, and this length is termed as magnitude of vector. Like if you want to represent, suppose force of 10 Newton. So we will represent it this way. This scale is hypothetical scale. Okay. If we are representing F equal to 10 Newton in this way, then we will represent half of this length as 5 Newton. Clear? So it is a hypothetical scale. We can make our own scale. So length is like not mandatory in this. And what is the magnitude? How do we say magnitude? Magnitude is the length of this. And how do we write? We write it with a modulus function in this way. Clear? So vector has a representation. Geometrically, vector is represented with a line and arrowhead including the direction of vector, and mathematically it is represented by an arrowhead. And how do we represent magnitude? Magnitude is represented in this way with a modulus function. Clear? Then one of the most important points which we need to keep in mind, the first important point is a vector is displaced parallel to itself does not change the vector. This means parallel shifting of a vector does not change the vector. If we shift a vector parallel to itself, yani ki without changing its direction, if we try to shift it and without changing its magnitude, then vector will not change. A vector and B vector both are equal vectors. Similarly, if I try to shift it here, if I do not change the magnitude and direction, then A vector is also equal to C vector. So parallel shifting of a vector does not change the vector. We need to keep in mind, because neither the direction nor the magnitude gets changed. Clear? Then next part, if the vector is rotated through an angle, then yes, it will change. If your vector is rotated by some angle from here to here, then directional component will change. So A is not equal to B vector. Then we can say this. Clear? Let's come to next point. Two vectors are called equal, just like we have studied now. Two vectors are called equal if their magnitudes and direction are same. That means A vector equal to B vector when their magnitude, that is the length, and their direction of their arrow, both are same. Then we can write they are equal vector. And they represent the same physical quantity also. That is also true. Like A must be velocity, then B must be velocity. If A is force, then B is also force. Clear? Yes. Then there comes a point where we need to find angle between two vectors. How do we define angle between two vectors? See, this is an important point. Angle between two vectors is the smaller of the two angles between the vectors when they are placed tail to tail. Like you need to join vector from tail to tail. Two vectors are there, they are joined tail to tail. Then there are two angles that we can define. One is suppose theta and the other one is alpha. So which one will be termed as angle between vectors? So it is the smaller of the two angles. So this will be termed as angle between two vectors. Now if you see here, in this one vector is A, other vector is B, but they are not joined from tail to tail. Now what we will be doing? Let's shift this from here to here. Parallel shifting of vector does not change the vector. Now we have joined them from tail to tail, and this will be the angle between two vectors. So in this diagram, how we can represent? This is not the angle, this is not the angle, this is the angle between two vectors. That is, angle between two vectors is angle between their directions. If you see the direction of A, it is towards this side. If you see the direction of B, it is towards this side. Then it is the angle between their directions. Clear? Let's see how well you have understood. Three vectors are there, A, B and C. they are making, x is making 30 degree with x, b is making 30 degree but in downward direction, and c is making 45 degree. What is the angle between a and b? What is the angle between a and b? So see, suppose you make a x-axis, so vector a is in this direction, vector b is in this direction, so this total angle would be 60 degree. Clear? 30 plus 30. Then what is the angle between b and c? B and C, if you parallelly shift it here, so what you will write, this is x-axis, then we have b vector here and c vector here. This is angle 30 degree and this is 45 degree. So what is this angle between b and c? Angle between their direction, what is the angle? So the angle would be 15 degree. What is the angle between a and c? A and c, if you parallelly shift it here, what is this angle? 30 degree. And if you add these two, what you will get? 45 plus 30, that is 75 degree is the angle between A and C. So this is how you calculate angle between two vectors, and this is how you apply the concept of parallel shifting of vector. You can shift a vector parallel to itself without changing its direction and magnitude. That is important. Now let's come to the point of unit vector. What is unit vector? How will you define a unit vector? See, unit vector is a vector which is obtained by dividing a vector with its magnitude. If we divide a vector by its magnitude only, then we will get a unit vector of that parent vector. This is your parent vector, and this is your unit vector. See, let's see, suppose this is my A vector, parent vector. We have a length, we have a direction. Now I want to find unit vector of this A vector. What I need to do, I need to divide this length, suppose this is 10 Newton, I will divide this 10 Newton by 10 only. Magnitude is 10, so we will divide it by 10 only. So what we will get? We will get a vector of 1 unit, a vector of 1 unit length, and direction is same. So this we call as direction of A vector. That is, it has a direction of A, but its magnitude is 1 unit. This is one such property. Now if you read the definition, vector which has a unit magnitude and points in particular direction, particular direction means the direction of parent vector, and any vector can be written as a product of its unit vector in the direction with its magnitude. That is, if from this definition, if I want to write, how we can write A vector is nothing but magnitude of A into direction of A. So vector has two components, one is the magnitude component, other one is the direction component. So this is how we define a unit vector. Divide a vector with its magnitude, then we will get a unit vector. Clear? Now, some properties of unit vector are like, unit vector has no dimension and units. It has no dimension and units. Then, unit vectors along positive x, y and z axis. Some standard unit vectors are which we call as I vector, j vector and k vector. That is, unit vector along x axis is I cap, unit vector along y axis is j cap, and unit vector along z axis is k cap. Now, if I want to write force of 10 Newton but along x axis, so we can write 10 Newton but direction is of I cap. So what it would be 10 I cap. So we can write any vector in this form, 10 I cap and then Newton, unit would be there. And one more important property, because we have already said it has a unit magnitude. So magnitude of I cap, magnitude of j cap, magnitude of k cap, all are unity. Their magnitude is 1 only. Clear? Fine. Let's go to the next topic. Let's see this example. A unit vector along east is defined as I cap. East direction, suppose we have east, west, north and south. East is the direction of I cap. Unit vector along this direction is defined as I cap. A force of 10 power 5 dyne acts along westward, then represent this force in vector form, in the form of I cap. So force is acting along this direction and its magnitude is 10 power 5. How will you represent this in vector form, not in representative form? If you want to represent in vector form, so it is opposite to I cap. So we will write negative of I cap minus I cap and its magnitude is 10 power 5. So this is how we will define a vector in I cap, j cap and k cap form. Clear? Yes. So these are the standard vectors, standard unit vectors. Now we have a small topic. If what happens when we multiply a vector by a scalar quantity? Like if you multiply a vector with a positive number. So suppose you have vector A and now you want to multiply, you want to get what is 3 times A. So suppose this is a B vector. So what is B vector? 3 times its magnitude. 3 times its magnitude A and A. 3 times A and direction is of A vector, parent vector only. So whose magnitude is changed by the lambda units but direction is same as that of A. Okay. So if lambda is positive, so its direction will not change, only the magnitude will change by multiplying with the positive scalar quantity. And when we multiply a vector by a negative scalar quantity, then what we will get? Suppose this is my A vector. I want to write or maybe represent lambda equal to minus 2A vector. So what will? Minus sign says the direction is opposite, but the length is 2 times that of A. So this is minus 2A vector. Length is double that of A, but direction is opposite to that of A. So this is your B vector. Fine. So by multiplying with a scalar quantity, its magnitude changes when it is positive, and its magnitude and direction both can change when lambda is negative. Clear? Yeah, this we need to keep in mind while we will solve problem. Now we have a problem how to add two vectors. Vector addition is different from scalar addition. In scalar, we can add 2 plus 2 as 4, but in vector, 2 I cap plus 2 j cap is may not be equal to 4 only. Fine. 2 plus 2 may not be equal to 4. So we have a law which we call as parallelogram law of vector addition. It says if two vectors can be represented by adjoining side of a parallelogram, if two vectors can be represented by adjoining side of a parallelogram, then its diagonal drawn from the same common point will represent the addition of A and B. Addition of both these two vectors, both in terms of magnitude as well as in direction. Like if we have a vector A and we have a vector B, I want to add A and B. So what I need to do? The diagram of this parallelogram, drawn from the same common point, will represent A plus B. This is how you represent resultant vector, and this is called resultant vector. This common diagonal will form resultant of A and B, or you can simply say sum of A and B. Now my problem comes to what is the length of this? What is the length of this? If angle between two vectors is theta, angle between A and B is theta, then magnitude of the resultant would be A square plus B square plus 2AB cos theta. What would be the resultant magnitude? Under root of first vector का magnitude का square, second vector magnitude square then twice of first vector magnitude, second vector magnitude, and cosine of angle between them, and square root. Clear? So you will write this is the magnitude of A plus B. This is how you will write. And how will we find the direction of the resultant vector? See, suppose, let us suppose this is making an angle phi with the vector A, and if we break this vector B, because after parallel shifting this will also be B, and this angle is phi, so we can break B into these two components. After resolving this into two components, we can write this side is B cos theta and this side is B sin theta. Small simple trigonometric ratio you can use. Cos theta you can write this side by B, sin theta you can write perpendicular by hypotenuse. So you will get this side as B cos theta and this side as B sin theta. And if you will use this triangle, the triangle PNM, so you can write tangent of theta from this triangle, MN is the perpendicular by base, which is B sin theta upon A plus B cos theta, because this total length would be A plus B cos of theta. You can write. So in this way we will get the direction of resultant vector. So we have a magnitude, we have a direction of resultant vector. So how to add two vectors using parallelogram law? Simply represent the two vectors as the two adjacent sides of a parallelogram. Then its diagonal drawn from the same common point will be representing its resultant both in terms of magnitude as well as in direction. Clear? The magnitude length would be A square plus B square plus 2AB cos theta, and the angle would be B sin theta upon A plus B cos theta. Clear? Yes, you can also write in inverse form. Now, there is another law, triangle law of addition. What it says? It says if two vectors can be represented by A vector and B vector. If two vectors can be represented by two adjacent sides of a triangle taken in same order. Same order means where the first vector ends, second vector starts from there. So if the two vectors taken in same order can be represented by two adjacent sides of a triangle, then the third side of the triangle taken in opposite order will represent its resultant, sum of A plus B, and angle between A and B, this would be the angle theta. Then we can also write magnitude, again everything will remain same, A square plus B square plus 2AB cos of theta, and we can solve it further for angle also. If you can write tangent phi, so tangent phi also we can write it will be B sin theta upon A plus B cos theta. We can solve it like this. And if we extend this rule, like one vector, then another vector in same order, then the third vector in same order, second vector, third vector, fourth vector, fifth vector. So where the fifth vector ends and first vector starts, so if we join the last and first point, then we will get the resultant. So the resultant would be A plus B plus C plus vector addition of all these vectors. Vector sum of all these vectors would be this only. This would be the direction of resultant and this is the magnitude of the resultant. And this we term as polygon law. This we term as polygon law of addition, extended version of triangle law. That's it. Clear? So both the laws are same. Parallelogram law and triangle law both will give you the same result for angle. It's just two different way to look at the same problem. Clear? Yes. Let's see few of the important points about resultant vectors. If we see three different cases, resultant vector of two vectors which are parallel to each other, that is, resultant vector will be maximum when cos theta is maximum. When cos theta is maximum, then r will be maximum. Cos theta is maximum when it is equal to 1, then theta must be equal to 0 degree. That is, vector must be parallel to each other. That is, if A vector is this, B vector is this, then A plus B, how we can add? A and B, if we can write this, then this will be the resultant, A plus B. If angle between them 0, then resultant will be maximum and it will be equal to magnitude of A plus magnitude of B. Clear? Then we can see when the resultant will be minimum. If we add two vectors and the resultant will be minimum when? Resultant will be minimum when cos theta is minimum, which is equal to -1. That is, theta must be 180 degree. That is, vector must be anti-parallel to each other. Then the resultant will be minimum, and minimum resultant would be in this case A minus B. But how will you get this? Put this value here. You will get A square plus B square minus 2AB. Then you can write it A minus B whole square, and whole square and under root gets cancelled out. So it will come out as A vector minus A magnitude minus B magnitude. And if vectors are perpendicular, orthogonal to each other like this way, if this is my A vector and this is my B vector, then we will have this parallelogram. Then what is the parallelogram type? It is a rectangle. And how will we get this side? R magnitude you can write as under root of A square plus B square, because angle between them is 90 degree, and for 90 degree angle cos theta will be 0. So you will get A square plus B square square root. Clear? So this will be your resultant vector when vectors are orthogonal. So you need to keep in mind, if vectors are parallel, the resultant would be A plus B. If vectors are opposite to each other, then resultant would be A minus B. And if vectors are orthogonal, perpendicular to each other, then the resultant magnitude would be under root of A square and B square. Clear? Yes. What is the range of resultant? So we get range of resultant as R max and R minimum. This is the minimum value. So range is like from minimum to maximum we can get. What is the value of R? We can get as maximum and minimum. So it would be magnitude of A plus B. This is the maximum value. And what is the minimum value of R? Magnitude of A minus B. So this would be the range of vector. So resultant of two vector can have any value from A minus B to A plus B depending upon the theta, depending upon angle between them. And the magnitude of the resultant decreases as theta increases. You can remember this. As theta increases, their R decreases. So you will write, if theta increases, then R magnitude decreases. This is the relation. As the angle between vectors increases, their resultant decreases. Clear? Yes. And two other important notes which you can remember. They are also getting asked frequently in your mock tests also, in your books also, and in exams also. So you need to keep it like a very crisp note in your notebook. Minimum number of unequal coplanar vector whose sum can be 0 is 3. This is asked. How many minimum number of unequal coplanar vectors whose sum can be 0 is 3. They must be unequal, they must be coplanar, and their sum must be, their resultant must be 0, then such vectors are 3. How? See, if this vector is A and this vector is B, this vector is A and this vector is B, then we will have this vector as A plus B. Then to get a sum as 0, just a minute. To get a sum as 0, the net resultant 0, then we must add a third vector which is equal and opposite to A plus B. So how we will get? If we add a third vector which is equal and opposite to A plus B, so 1, 2 and 3, these three vectors can give a net 0 vector sum. Clear? So minimum 3 coplanar vectors are required to get a net 0 resultant. And for non-coplanar vector, the resultant of 3 non-coplanar vector can never be 0. This is one such point. And the minimum number of non-coplanar vector whose sum can be 0 is 4. So you need to remember these 2 points also. Point number 1, minimum coplanar required to get a 0 resultant is 3. The resultant of 3 non-coplanar vector can never be 0. And minimum 4 non-coplanar vectors are required to get 0 resultant. So this is the 2 takeaways that you can note down. Let's solve one problem based on parallelogram law. A vector makes 30 degree, vector A makes 30 degree and vector B makes 120 degree with the x-axis. Then the magnitude of these vectors are 3 and 4 units, then respectively. Find the resultant, magnitude of the resultant clearly. See, this is x-axis, this is y-axis. Now vector A is having a 3 unit magnitude and it makes an angle of 3 unit magnitude and it makes an angle 30 degree. Vector B makes 120 degree. Vector B makes 120 degree angle with x-axis and its magnitude is 4 unit. Then what is this angle? This angle is 90 degree between vector A and B. Then how we will find the resultant? So the resultant would be in this side. So this would be your R. What is R magnitude? Angle between two vectors is 90 degree only. So we will write angle between two vectors is 90, then the resultant would be 3 square plus 4 square. What we will get? Under root 25. Then its resultant would be 5 unit. So we'll get answer as C. Clear? Let's solve next problem. Two forces of magnitude 3 Newton and 4 Newton are acted on a body. Then the ratio of magnitude of minimum and maximum resultant force on the body. What is R minimum? Resultant minimum. So you will get 4 minus 3. Difference of the two, 1. What is R maximum? You will get 4 plus 3. You will get 7. What is the ratio of magnitude of minimum and maximum? 1 upon 7. So you will get 1 by 7 as your answer. Clear? So these are the simple types of questions that are frequently being asked. Next, if you solve this question, 3 forces are acted on a body. Their magnitudes are 3 Newton, 4 Newton, 5 Newton. Then acceleration. See, acceleration kya likha hai? Must be 0. Then second, acceleration may be 0. Then the third part of the body, acceleration must not be 0. Must not be 0. See, we need to add these 3 vectors. This is F1. F1, it is 3 Newton. It can be in any random direction. F4. And this is suppose F3. It is 5 Newton. As the directions are not prescribed in this question, so we can have any random direction for these 2 vectors. These 3 vectors. So, can we say their sum can be 0? Yes, for some cases their sum can be 0. So, net force is 0 and acceleration is, how will you write? Force net divided by mass. If we say the net sum of all these 3 is 0, it is possible only for few of the alignments. For few angles, it may be possible. When it will be possible? Like if 3 is in this direction, 4 is in this direction, perpendicular to each other, then we will get this as 5 unit. And if third vector, this is your F1, this is your F2, and if this is your F3, which is opposite to this, then for this case, they will get cancel out and we will get a 0 resultant and acceleration will be 0. But if this is not the case, then force may not be 0 and acceleration may not be 0. Clear? So, for few, acceleration of the body may be 0 or may not be 0. So, we can write this would be the answer, because these are saying, these two options are saying must be 0. So, that is not true, not true. They are true only for few of the cases where alignment is fixed. They must be defined that vectors are at this angle with each other, then their resultant can be 0. Otherwise, for general cases, their vector sum may not be 0. Suppose if the three vectors are parallel, all three are parallel, then what would be the resultant? 4 plus 3, 7 plus 5, 12. So, 12 would be the resultant in that case. Clear? Yes. Find the resultant of two forces, each having a magnitude of F0 and angle between them is theta. See, we need to find the resultant. One vector is F0, another vector is also F0 and angle between them is theta. Then, how would we write the resultant? We will be writing F0 square plus F0 square plus 2 F0 F0 cos of theta. Then solve it further. We will get 2 F0 square plus 2 F0 square cosine of theta. Then the final resultant for this case would be root 2 F0 square and 1 plus cos theta you can write. So, you will get root 2 F0 and we will be writing it as 1 plus cos theta. Clear? And this can be solved further. See, one thing you can leave it in this form only, and if you want to further solve it, so we can use a mathematical formula. 1 plus cos theta you can write as 2 cos square theta by 2. You can use this half angle formula. This term can be written as this. Okay, we will use this trigonometric relation and it can be reduced to root 2 F0. 1 plus cos theta can be written as root 2 cos square theta by 2. And it can further be simplified. Root 2 is 2 F0 and it will come out as cos theta by 2. So, this can be the final reduced form for resultant of this. Okay. So, it depends upon the option whether you want to convert it in this form or whether you want to leave it for this form. If angle is given, then this can be calculated. Fine. And one more note you want to take it from here. If theta is 120 degree, that is, if vectors are having equal magnitude and angle between the vectors is 120 degree, then you will see the resultant would be 2f0 cos of 120 degree by 2. So, what you will write? 2f0 cos 60 degree. Cos 60 is half. So, we will be getting f0 only. That means, if angle between two vectors of equal magnitude is 120 degree, then the resultant will also have a magnitude of f0 only. Clear? That is, you can keep a note, if angle between two vectors is 120 degree, then the magnitude of resultant will be equal to the magnitude of individual vectors only. Clear?